So, ceiling reflectors, absorber at rear to avoid long delayed, that is what it is. If you put absorber at the rear, long delayed reflections will be taken care of. And 7.5 meter from the proscenium shall not be treated for parallel wall to avoid flutter echo. Not treated with reflector, you can put absorbers. If it is a brickwork, it will automatically be absorbed. That is what I am saying, 7.5 meter from the face of the stage or proscenium, So, that is what it is. So, that is what it is showing. This is the reflector again, reflector design I am showing again, right. So, this is how we do the ceiling reflector, and this is I am just repeating. So, this is the length of the first reflector. Then the second reflector, I wanted to decide it, I decided to actually reinforce from here. So, what I do is I join this line, divide this, and then normal to this, and I decide that reflected sound should reach there. So, it is just same thing drawn again, and this is my profile then, and you can carry on this one to get the right kind of ceiling profile. So, that ceiling reflectors actually, and this is how it is. So, reflected sound must reach the rear from the ceiling, it must reach the rear, or even from the near the proscenium wall, it should reach the rear, should not come back. So, therefore, no parallel wall, right. So, that is what it is. Floor shape, okay, floor shape is an important issue, because if you like this diagram will make it possibly clear. Supposing this is my source height and this is my source, receivers. Now, the ray from the source passing over the head of the front seat and ray passing over the head of the rear next seat, I need sufficient gap between these two, otherwise I will see only the back side of the head. The angle reduces as I go far away, this angle. So, this is called head clearance, this is called head clearance. Now, head clearance, if my floor is flat, this angle will reduce, here for example, somewhere here from the same source and somewhere here from the same source, this angle will simply reduce, and if I go far beyond, I will not see, the person on the rear would not see anything, because the head will come and block it. So, I need sufficient head clearance. So, what we do? We provide therefore slope, raise this point up, so that this head clearance increases. Now, there is formula for this and there is algebra behind this actually. So, I will just talk about that. So, this is called head clearance. Is it clear what is head clearance? Head clearance is the difference in height between the ray reaching the front seat and the next rear seat, right. So, this is the height. See, this is from the front seat, ray is coming from the front seat, and this is coming to the next seat. So, this is called head clearance H, and this is the height of the source. So, simple geometry, this is the distance between two rows. So, this H, this two triangles, similar triangles. So, this is R, this is distance is the head clearance, this is the spacing of the row. So, H minus H divided by S is this distance, S minus, so this H by R, this is H, this is R, is equals to S is the distance not requiring slope. First is S is the distance not requiring slope. So, if the head clearance is sufficient, I won't need the slope, I will need the slope. So, I want to find out what is the value of S up to which I do not need any slope, it can be flat. For example, here they have provided a slope right from the beginning, I am not very sure this was necessary, right. This is just intuitive sort of, without going into the thinking part of it. It is okay, it looks nice, that is not a problem, but you can avoid providing slope up to certain distance, right. So, this distance is S, where because S is the distance up to which I do not need slope. So, up to this distance let us say I do not need slope. S minus R is this distance, S minus R divided by H must be equals to R divided by, or H by S minus R is equals to H by R. where S is that distance up to which I do not need raising of the flow. So, this is the formula. So, S is given by R plus R h by h, where R is the spacing of the seats, right. H is the height of the source, typical height of the source, and this is the head clearance, and these values are actually given in the code. So, this is S, as I said, and these values are given in the code actually, or guidelines are available. Let me see, I will come back to this algebra part of it later on, but let me see, there are two formulae, I will come to that, but let me give you the value first. Typically 8 degree is good, typically 8 degree is supposed to be good. Let me see if I have somewhere written it down there. Head clearance should be, no, I think I missed it, or maybe it is there somewhere, I will find it out. 12 it is written, 12 centimeter minimum for seats one behind the other. But if I have staggered seating arrangement in plan like this, and next row is something like this, staggered seating arrangement, then I can go for 8 centimeter as a head clearance. So, minimum head clearance should be 8 centimeter or 12 centimeter, and a rule of thumb is that 8 degree minimum slope, 8 degree minimum slope, 8 degree should be the minimum slope. We do not need, because it will be uncomfortable even going through the steps if it is more than that. So, 8 degree is one thing, rule of thumb, but you can actually design this as we shall do right now, right. So, 8 centimeter staggered. So, this is what it is. So, this formula we have talked about up to S. So, you can calculate out if you know the spacing. Spacing is decided based on row spacing is decided based on what kind of seat you have, what sort of comfort you want to give. For example, in like you want to give lot of space, then but minimum should be 0.85 centimeter, 0.85 meter. I will come to that. I will come to that later on. So, this is minimum. You want to give lot of comfort, then you increase it, right. H we have said 12 or 8. So, R we are talking about, and height of the source would depend upon performance. Now, as I said, the YT other day I was just saying they kept the speaker somewhere around 5 meter height. It is all ridiculous. You do not need to have 5, why do you need 5 meter? If you put it somewhere there, it will go somewhere, the sound will go somewhere there. Unless you want to send the sound away. And it was also convex like this, which means that this sound will go somewhere there. It is not going into the auditorium, it is actually misuse of the whole energy. You are not using the energy properly, no idea basically. So, this is not required. This is not required, number 1. This is not required. So, this is the formula. So, we can actually calculate it out. Now, to find out a formula, there are 2 ways we can find out the formula. 1, consider a point up to S you do not need any raise of the flow. Let us say consider 2 points where I need some raise of the floor. So, this is my ray from the source, and this should be the head clearance, and this is the this line, this is the normal head level without any raise. Head level will be somewhat higher, it is the head level, we are talking of head level, because hearing at this level, So, head level, eye level, etc., generally we talk of head level. This is the elevation of the seat, E is the elevation of the seat, H is the head clearance, height of the source is H from the proscenium, or you can So, this is your this itself is E. So, if I draw a line like this, parallel line, horizontal line at the head level, this is E. So, therefore, if I extend this, spacing is R, and H is this, H minus E is this distance, H minus E is this distance, this small distance, H minus E is small distance. So, H minus E divided by R, this triangle, if you look at this triangle, this is H and H minus E is this distance, H minus E is this distance. So, H minus E divided by R is equals to, is similar to this triangle, which will be H minus raise of the previous one has been already raised to E n minus 1. I am interested in E n, elevation of nth row, elevation of n minus 1th row. After up to certain row I will not require any elevation, but after that row number 1, row number etc., n minus 1th row has the elevation E n minus 1, and nth row has got the elevation this. So, difference is E, this is the E, the elevation of the nth row over and above n minus 1th row. So, this is what it is. So, H divided by H minus E divided by R, you know this small triangle, as you see this is R, this is H minus E divided by R, that is equals to this height divided by this length. This height is H minus E n minus 1, because this is the elevation of this row, this was H, this whole thing is H, and this much is the elevation of this row is E n minus 1. So, the reduction originally there were up to the floor level there was like height from the normal head level I am talking of. So, this is the H in E n minus 1, S plus, and this distance is how much, S plus R, because R is the spacing, and n minus 1th row is this row. So, R into n minus 1, S plus every row spacing is R, n minus 1 row which required elevation the previous row is R n minus 1. So, this from geometry I can actually arrive at this. H is known to me, which will be either 12 centimeter or 8 centimeter, R spacing is known to me, and S is known to me, which I have already calculated earlier, the row up to which I do not require any elevation. So, for each row after that, for example, first row, for the first row n equals to 1, this value is 0, and this is simply S. So, I can go on calculating step by step elevation of difference in elevation of each row from the previous row. So, E n will be given by this E n minus 1, because E is here from this formula, this is E equals to E n minus 1. So, I put here E n minus 1, I get this sort of an expression, because R multiplied by whole of this, R multiplied by whole of this plus H. So, this is the expression I get. So, for E n, elevation of nth row, elevation of n minus 1th row, H, because this will be multiplied here by R, and then E will go, E will go to the other side, H minus this comes in, right, H by R. So, this R I have already multiplied. So, and E is nothing but E n minus 1. So, E equals to, I can find out E from this, E will be simply, E will be equals to R into H minus E n minus 1 divided by S plus R into n minus 1 E, and E then I write is and this sorry E will be equals to no H minus E will be this. So, E will be equals to H minus all this, and E is nothing but E n minus E n minus 1. So, I can get an expression for E n equals to E n minus 1 plus H, etc., etc. So, this is known, step by step I go. First I find out for the first row requiring elevation, then find for the second row requiring elevation, and every steps will be different. Well, for construction purposes you might like to make it as close as possible. Steps cannot be too different, but just but this is how one can calculate out the full slope. So, that is how one can actually calculate out the full slope. But there is another way of calculating it also, using principle of what is called logarithmic sphere, logarithmic spiral, where this angle is constant, this angle gamma is constant, angle it makes. So, anywhere for the last set it makes this angle, the slope this line and this angle, and here also this line and this floor line, from the source to the point head level. If I join with the head line, the angle it makes is gamma, and here again with the floor line, the head, so this is my floor line, this is the head line. So this angle is gamma, this is constant, this is called logarithmic spiral. Now if this angle is constant, then I will be able to see all the time, everybody will be able to see. That will correspond to 12 centimeter or 8 centimeter. Gamma is such that it will correspond to 12 centimeter, or every time the angle is constant. The last sheet, the curvature, this angle and angle with the source, this angle is constant. It is because of this angle which we drawn earlier and then try to geometrically find it. So this is called logarithmic spiral. Gamma is constant, remains constant, and gamma is nothing but Hs by S. This is nothing by my S d0, which does not require any elevation, right. So the gamma is simply Hs, height of the source, normal height without floor raising, height of the source. So gamma is simply Hs divided by S, Hs divided by S, right, and that's one. And in this, otherwise I will have to basically at any distance, the distance is Rn. So I can actually get an expression like this. So the R which will maintain the distance, this R which will maintain this constant gamma, or for equation for logarithmic spiral, is given by this R0 e to the power theta cot gamma, right. So what is theta? Theta is shown as this as the angle. So theta 1, theta 2, theta n for any point, nth row, first row it will be theta 1, first row requiring elevation value is theta 1, second row theta 2 and theta. So it is given as e to the power R0, this is the R0 e to the power theta cot gamma. This maintains constant gamma angle, if it is, this is given by this curve, and it can be approximated to R0 e to the power gamma by theta. This one can be approximated to R0 e to the power gamma by theta by gamma. So theta one can write by taking ln both sides, theta by gamma is equals to ln r by R0, because r equals to R0 e to the power theta by gamma. That is actually an approximate equation of logarithmic spiral, right. So logarithmic spiral satisfies this requirement of maintaining a given head clearance. If the gamma angle remains constant, it will maintain constant head clearance. So if I take ln of both sides, ln r by R0 is equals to e to the power theta by gamma. So yeah, so what is it? So sorry, this will be theta by gamma simply. So theta will be gamma ln r by R0. Now what is theta? This angle we take same as this angle. So which is simply theta is distance divided by, theta will be this, theta n is theta n would be, can be written as d divided by d0. D is the distance at any point, horizontal distance by any point. So this, if this is this theta, I am interested in theta n, I am interested in any theta for that matter. So theta is given by ln d, r by R0 is r by R0. What was r? R is this distance. So this, and R0 is this, or d0 is this distance, R0 is this distance, R0 is this distance. This is approximately same as the in the ratio of the horizontal distance. D0 by dn is equals to R0 by Rn. That is what we are saying. So R0, r by r. So that is what we are writing. So theta is written as gamma n ln r by R0. And what is theta? Theta is Hs divided by, because just let me just clear it up a little bit more. Theta n is this distance, this angle is same as this distance. So this is gamma. So theta minus gamma into d. So this is, if I draw a horizontal line at any point, this corresponds to our, this angle is same as gamma, this angle is same as gamma. So theta minus gamma is this angle, which is nothing but this height hn, hn height of the elevation height minus hs. So hs, this is this this is hn is the elevation height minus hs. So hn minus hs is this height. This is equals to this divided by dn, this divided by dn, this length is equals to theta minus gamma, theta minus gamma. So, from this it follows dn into theta minus gamma is equals to hn minus, approximately one can write hn is equals to hs plus theta minus gamma into dn. How? This line I draw a horizontal line, this angle is same as this angle. So, this is gamma. How much is this angle? Theta minus gamma. So, this height is how much? hn minus hs, height of the source minus the height, elevated height of the head, head level. So, hn minus hs is this height. So, this height divided by dn is equals to, this is d, this by dn is equals to theta minus gamma. This height divided by this distance is equals to theta minus gamma. So, this is hn minus hs, hn minus hs is equals to hn minus hn is equals to theta minus gamma divided by dn, of course, dn, this distance, total distance is equals to theta minus gamma. From this it follows here. So, therefore, hn I can find out. So, essentially height, head height of nth row is given by this formula, where hs is the head height of the source, without height of the source from the head level, basically height of the source from the normal head level in the without requiring elevation. So, height of the source over and above normal head level is given as hs. hn is the head level or elevation, actually hn minus hs is actually the elevation of this row, this elevation of the nth row. So, that can be obtained from this formula, where what is theta? Theta can be obtained as hs divided by d0. Theta can be obtained as hs divided by d0. Let us see, I think we are. So, hn is equals to, the, if you go back here, gamma is hs divided by, because the slope here, this is slope, at any point this angle remains same, gamma, any point you measure this slope, this angle is gamma. So, here the gamma is hs divided by d0 or s. So, gamma is hs, basically this was hs, which is gamma d0, and this is d1 ln, because from this one it follows theta is equals to gamma ln d by d0. So, I put it here, theta equals to gamma ln d by d0. So, I will get hn equals to hs plus theta is dn multiplied by gamma ln d by d0 plus gamma dn, So, this is what is done here. So, dn gamma ln dn by d0, because this is theta minus gamma dn. So, gamma can be taken out from everywhere and you get something like this, gamma into d0 dn, etc. So, gamma required for the head clearance, that you can find out, that would be height of the source divided by the first row not requiring any elevation, height of the source divided by, so from that actually, so s d0 is nothing but s, and dn is distance of the row from the source, and everything else is known to us, we can actually find it out. So, one can actually use this also formula to find out the floor shape, one can use this to find out the floor. Okay, quickly just rounding it up, preferred shape is fan shaped. This is my proscenium, this fan shape, because everything will be reflected backward. Floor area of hall including gangways, this is given in the for per unit area for considering general type of auditorium, 0.6 to 0.9 square meter per person, ergonomics and everything put together, including aisles, movement and things like that. Average height should be 6 to 7.5 meter, and volume per person depends upon, because volume controls the reverberation. So, volume per person for lecture hall theatre, it is lecture halls it is 3.5 to 4.5, cinemas 4.5, to 5, 4 to 5, and music and concert hall you require more, because reverberation time T is a function of 0.16 V divided by S alpha bar, if you remember that. So, higher the volume, better is the reverberation, it will remain in the space for longer period of time, reflected sound will come later, right. So, mean free path and all that we discussed about. So, therefore, music you need more per person. This is given in codes actually, 2526 IS code also gives the same, and angle of the side wall, this wall, because side walls, for example, this is my stage, right. Now, this angle should not be this, this angle should not be angle of side walls 100 with the curtain line. So, this is my curtain line. Let us say this is my stage, this is my curtain line. This angle should not be more than 100 degree. If it is more than 100 degree, means it is going to be flatter like this, which means that visually somebody sitting here won't be able to see anything. If it goes like this, somebody sitting on that corner will miss the other corner of the stage. So, viewing becomes difficult. So, within 100 degree you can see that. Distance of the rearmost seat should be not more than 23 meter from the curtain line for viewing, otherwise you provide balcony. So, angle subtended by highest object with horizontal plane at front seat should not be more than 30 degree, like otherwise you have to look vertically up, very uncomfortable. So, in case of cinema this is very important, the top of the screen and the headline of the first seat, that should not make more than 30 degree, otherwise somebody will have to raise their head and see. This is very uncomfortable seeing all the time like this or moving your head in this manner. So, this should not be. So, therefore, cinema should be 3.6 meters, top of the screen should not be more than 3.6 meters, and drama, because here drama is also you view people, drama you view people, therefore 4.5 meter is a is a seat distance, minimum distance of the seat. So, minimum distance of the seat is 3.6 meter, 4.5 meter, because 4.5 meter, because like in case of drama the height is less, whatever it is. So, it is related to that actually. Width of the seat 45 to 56 centimeter, row spacing 0.85 or more, 106 for upholstered seat, giving lot of comfort. Music requires blend, balance, fullness, I told you already, hence high reverberation time, and speech discrete sound requires less reverberation time. Cinema requires less than music, because there is some amount of reverberation built in the soundtrack itself. If you have seen a film of good old days, you will find on the corner there is a soundtrack, blank spaces, right. So, those soundtrack already has some reverberation built in, and one can use Savine's formula 500 hertz to provide absorber. So, the last of the slide is, this is from IS code straightway. It gives you the desirable reverberation time in seconds, volume in 100 cubic meters as a function of volume of cube. So, average for music is higher reverberation time. Orders are 1.4 seconds for 20 meter cube, 20,000 meter cube, 2000, 2000 meter cube, 2000 meter cube, because in volume in hundreds of cubic meters. So, 20 means 2000 meter cube, you need around 1.4 seconds desirable reverberation time. For speech you require much less, because speech is discrete sound, which I told you earlier. You do not want sound to persist for long period of time, in fact it can distort. School auditoriums are generally meant for multi-purpose. You have sometimes speech, sometimes drama, sometimes music. So, it is a compromise somewhere in between. Motion pictures have both speech as well as music. So, it should be something close to the school auditorium, but it has got built in reverberation. So, therefore, this is kept somewhat below. So, this curve is something like this in log scale, as you can see. The order of these times are from about 0.8 seconds to 2 seconds and so on. This is the order of the reverberation time. So, you know the desirable reverberation time you can calculate for without any treatment, and with treatment you can calculate out what is the reverberation time required, and the formula is known to us. We just use Sabine's formula at 500 Hz. So, absorption at 500 Hz is taken, typically that is what is checked for most of the auditoriums, and that is what is done, and you see that it is close to this value. If it needed, put some additional absorbers, preferably every absorber should be placed at the rear, right, but try to distribute them as best as possible, so that you get diffuse sound, or absorber should be placed close to the wall, close to the source to avoid flutter echo, that sort of situation. So, judiciously one can place the absorbers, but otherwise if absorbers are not required, reflectors are required, you do not polished, you can place polished things. So, quite often people add absorber depending on the situation, makes a calculation without the absorber, without any treatment, then calculate the reverberation time. If it is satisfying, fine. If it is not satisfying, then find out how much is the additional total absorption required or reduction in absorption required, and accordingly then you design your absorber, place them as you want. This will be random noise absorption, not one thing is random, besides that they will be coming from all angles. So, specific not necessarily specific frequencies, unlike the one that we talked about like Helmholtz resonators or similar sort of thing, which is specific frequency for noise control, if I know the frequency. Here it could be all kind of frequencies. So, such absorbers which can absorb at various frequency broadband, that is what one should be selecting. Sound reinforcement, somebody was asking about mics, where do you speakers, where do you put them? You can put them in appropriate places using these concepts that I talked about. There will be additional sources, and if you put additional sources, if you put them on the wall face to face, that will cause flutter echo. So, put them in such a manner, and such that it reinforces the direct sound as much as possible, or the number one speaker as much as possible. Conference room slightly more complicated, because you have more number of sources, not one, several sources. So, if you are doing ray diagramming, you have to do for number of sources, and open air theatre external noise is anyway there, adequate loudness level is important, because in open air theatre you will have no absorption at all, because it is all open space, and therefore adequate sound level is important, adequate I am saying, not excess. So, that is related to auditorium. I think we can stop here.